So I was like, I'll just listen to Hamilton. I just put my phone on shuffle. That's the first thing that came up. Anyway. Hey, everybody. It's Thursday. It's time for concrete. So we're working now on designing beams. That we don't know the dimensions of. And just a few rules of thumb to maybe start with some examples, to start with some dimensions, I mean. So I was just going to work through another example like we did in the videos. Put you guys over here. No, I don't want that. This can go away. All right. So we just did I had one that was a cantilever, and now we'll just do a simply supported beam. So our first thing that we got to do is see how much strength we need. Anybody want to go ahead and do that? Let me know when you got it. Somebody shout it out. Or at least shout out what the equation would be for a simply supported beam.
Yeah, I know the process. I just don't have that equation. I was trying to do the homework and I don't have that equation because I don't have my FE reference with me.
Okay.
So I didn't know how to get MU.
It should also be in, well, if you don't have your FE manual, I was like, there's some in your steel manual, textbooks, just Google it. But maximum moment is WL squared over 8 for a simply supported load, simply supported beam distributed load. Anybody got a number?
361K.
Mm-hmm. Give feet, yeah. Right. Fire. should give you that 361 cubic feet. Anybody not get that? So now we need to estimate a target reinforcement ratio. So we got 4,000 PSI. So my beta 1, 0.85. So this is about what we want to have for our reinforcement ratio, right? So now we can use design equation to get essentially a relationship between our beam width and then the depth to our neutral axis of our tensile reinforcement. It's going to be some number, right? So why don't you guys go back and look at the equations and see if you can do that.
Why did you estimate B as half of H? Is that just a rule of thumb in the previous
Yeah,
example?
generally it's like a third to a half.
So it's safe to assume that again, just go with half? Or is
Yeah,
there,
yeah. Anybody have a value for the BD squared or you're still working? It's fine. I'm just sitting here.
I got 6,471.7 inches cubed is equal to BD squared.
6,400 something.
6471.7.
Okay. I got a slightly similar number, but different probably with rounding. So anybody else got numbers like that? You could text it too if you don't want to talk. Still working. 6540. Yeah, I got 6537. I mean, it's just, we're estimating everything, right? This is all just to get you in the ballpark of designing. All right, so there's this equation that I wrote down, right? That's it. MU over phi is equal to rho Fy 1 minus rho Fy divided by 2 times 0.85 F1C dV squared. So 361 cubic feet times 12 inches per foot. And we're assuming it's tension controlled. Remember, we got to go back and check all this, but we're just assuming that. I ended up with a relationship between my width and my depth of something like that. Justin, you're in the ballpark, so it's probably
So on a side note, I was looking at the homework. And you want us to do the moment diagrams with self-weight. So we would basically do this to get an assumed B and H value, go back and calculate for normal weight concrete and add that into your dead load.
Yeah, I mean, it shouldn't change stuff too much, but
So do you have to redesign for your MU then using the new
just
weight?
see if it works or not, and if it doesn't work, then redesign.
Okay. But this is the method. You basically do this and then plug this H and B back into your dead load to calculate for weight.
Yeah, that's true. Yeah, yeah,
Yeah, because to calculate for your weight, you have to have those. So you're going to have to do this first.
yeah. So we've got this relationship. And then this is what I did. And obviously y'all can come up with, just using the rules of thumbs. This is another way to approach it if you wanted, I guess. I made a little chart. B, D, an approximate H, and just the relationship to H and B. So like if I made B 10 inches, I have a depth of 25.6. And if I assumed a layer, it's like 25.6, not 2.6. If I assumed one layer, right, so just add 2.5 inches to that. You have an H of about 28.1. So a ratio of 2.81. If I said a width of 12 inches, that would be a depth of 23.3 and a height of 25.8. With a ratio of 2.15. So this is just another way to say, like maybe pick a B and then calculate a D and an H from that and see what sizes you like the best. For this example, I went and chose 14 inches and 24 inches. You could choose like 12 and 26 or 10 and 28. But that's kind of long and skinny. Did anybody else go ahead and choose anything?
I chose 26 for H and 12 for B. That's what I had.
Yeah.
Because with my number, when I solved out for D, it was 23.48. Don't you have to add the 2.5? You said to round up, so I went with 26.
Yeah. So, and that's fine too. There's no wrong answer here other than for this example, if we all choose the same thing going forward. Right? For all I know, I stole this example from the book. I don't remember, but yeah. So from there, let's say we have a width and a height. Now you guys could go back to Now we're to known dimensions, right? So you can go back to the example we did last week. And with your known dimensions, choose a width of 14 and a height of 24. That's the height, not the depth. So you can say 21.5, right? Just assuming one layer, and so you subtract 2.5 inches. So go ahead and work on that. I'm going too fast, somebody yell.
What are we assuming for? Oh, I saw it. Never mind. I was going to ask about the stirrups, but it says on here number 4.
Yeah, so your first step is to start with an AS that you've estimated from the reinforcement ratio, right? And then just use the two design equations to converge on an area of steel. Or you could calculate it whatever we did last time too. You'll get the same answer. Anybody got a number they're willing to share? How much area of steel you need? Type it too.
I got 4.26, but that seems awfully high.
It is high.
I got 3.7.
You got 3.7. I got 4.26.
Yeah, 3.89.
I got 4.26. Where's the 4.2? Did you guys who got a different answer? Well, I'll show you what I started with. I started with an area of steel equal to that. So 0.014. That's just my estimated, right? Row. 14 inches. So I started at 4.21. And then I use the equations. Do I have them written down? Right, A equals the nominal. Make sure you use the nominal and not the, although that would increase your A. A equals A. Oh, wait a second. I have two equations correct. Right. And then 361 feet and 12 inches per foot divided by 0.9. Then it gave me, I made my little chart. Started with 4.21. Gave me A of 5.31. Gave me an area of steel of 4.26, which is an A of 5.47. And an area of steel of 4.26 again. Anybody else? Anybody have any questions about that? Maybe see where the calculations were different? That's a lot of steel. You're right. So we're probably fine with AS min. Um, so I have an area of steel that I need 4.26 inches squared.
So, like, if you get 4.2, is it okay to use something like that, or you always want to be over, never under?
You mean in choosing the bars?
Yeah. So, like, for your AS, if I choose some bars and I get 4.2 instead of 4.26, you need to go up. Because I'm having a hard time finding, like, a good fit.
Yeah. That's a good question. I mean, and it's like I feel like it's better to go a little bit over, but you could use whatever you get for 4.2 and check and calculate your nominal capacity. And if that's fine, then it's fine. You know, because this is all based off of a bunch of estimates anyway. It's just if
Just as long as in the end you're passing your nominal capacity.
right, your PMM
That's
is
really what
greater than
matters.
your MU, it doesn't matter. This is all just methods to determine how to design your beam, right? So let's see. I did it differently, I guess, this time. Right. If I did my number of bars and area per bar. If I have 2 bars, 4.26 divided by 2, 2.13. That would be 2 number 14s. Right. You're right, but 4.26 is a lot, and we're talking about 2 number 14s. Those are really big. I've seen them in person. They're not small. If I have 3 bars, 1.42, that would be, I'd need like 3 number 11. If I have 4 bars, 1.065. That would be like 4 number 10s. If I have 5 bars, now we're talking about something that's like 14 inches wide. I would need a bar that's at least 2 inches squared. That would be like 5 numbers. We're talking about something that's 14 inches squared, or 14 inches wide, sorry. So 5 number 9s is probably not gonna fit. Does anybody have a preference? Anybody got a, what would they choose? I don't know. I've checked the fit, and then I think I chose 4 number 10s. 3 number 11s would work, and 4 number 10s are gonna work.
So it's okay to be over that far? That's what I was having an issue because you're like, your AS for that is like over 5.
For 4 number 10s.
Yeah.
Yeah, it's okay to be over that. Well, I mean, it's okay as long as it still works. I guess if we do it like the other way,
I was trying to break it into 2 rows and I still couldn't get it very good.
yeah. And see, this is probably where, like if we go back to the sizes, well, the width is going to help us with the fit horizontally. And then the height is going to help us with that moment arm, right? So that'll increase our moment capacity. So maybe we would, if we were really having a tough time, maybe we would choose 14 inches and increase the height to try to increase, you know, if we were not tension controlled, if we increase the height. I'm gonna just say what I've done, which was 4 number 10. That's an area of steel of 4 times. right? I don't know what the number 11 would be. Again, this is where it's choose your own adventure, and as long as it all works, you've not done anything wrong. I mean, maybe everything else on the site is number 10, so it's like, yeah, let's just keep number 10s, or there could be other factors in choosing. All right, so let me just check our fit. And I seriously like draw this every time. We have our cover. The diameter of the stirrups is number 4, so half an inch. The inside bend diameter which is an inch because it's 2 times my stirrup. And then we have 3 spaces and 3 bars. So you can calculate a minimum width. We have a minimum width of 2 times my cover plus 2 times your stirrup diameter, 2 times the inside bend diameter. And then I have 3 spaces, and the spaces are either going to be a minimum of an inch, or sorry, the maximum of an inch, or the bar diameter, assuming the aggregate. Did I have an aggregate? Let's assume aggregate doesn't apply. The minimum spacing is 1.27 inches, because that's the bar diameter for a number 10. So I have 1, 2, 3 spaces with 3, and the number of bars is 1, 2 plus 2 halves, so also 3. So to meet minimum spacing requirements, I have to have a minimum width of 13.62 inches, and maybe it's 14 inches. So now you have the whole thing designed. We could try those breakout rooms again. Y'all could just calculate the CNMG. See if I can do that. So our final design is not to scale. And 4 inches by 14 inches. 1, 2, 3, 4. And number 4, 0. Go into some rooms and calculate PMN together and see if anybody has any questions. You guys got an answer already?
I accidentally left, so I don't know how to go back. But
Oh.
Everybody
Jasmine,
left me. Everybody left me alone.
I know, I was like, Jasmine's like, wait. I don't know how to, can you, I don't know. Here, you guys can go join Elizabeth and Ginny. They only got 2.
Yeah.
All right, Dr. Turner, we got the answer.
You do?
Yes. We got 415.
Yep.
That's what I got.
We're so smart. Look at us go.
I know. All right, I'll leave you alone. You guys can come back or just chat about whatever you want here. I don't know.
Alright.
Cool.
Now we're having fun over here.
Okay. Okay. Enjoy.
Oh, okay. I can't hear you, Dr. Turner.
Well, I'll unmute my mic then. Thank you.
I can hear you now.
You guys doing okay? I was just popping in.
Yeah, we just needed to compute A and then calculate VMN. Is that correct?
Yep. And check, make sure you're, yielding and all that.
Okay.
So, okay. Good.
Jonathan, did you say you got 415?
Yeah, that's what I got.
Okay, sweet.
Then I'll let you be.
Jasmine,
There you go.
Huh?
what did you get for your A and your C? Nothing.
Wait, what? Hello?
Nothing. Never mind.
Did you guys, yeah, have you guys gotten your A and C? Yeah.
I did.
I'm
got
gonna join
for
your group, so.
A, I got 5.36, and then C, I got 6.317.
I'm off. Okay.
I didn't get those numbers. What'd you get for your D?
Wait, didn't we get? Oh,
You
okay.
have to go back and kind of,
Yes.
I mean, it's gonna be a similar number, but you have to recalculate it.
Oh, were we supposed to leave once we got the answer? Since there's only 7 people left.
No, that's fine. No,
Oh, they're in their breakout room.
So Sway ditched Jasmine and so they came back to the main one.
Yeah, Ian and Josue did. They both just dished me in there by myself.
So we're just in the main one. I think actually I can bring everybody else back because well, actually I don't know what Elizabeth and Ginny are doing, but I know that other people. Okay.
Is concrete part of the FE exam? Dr.
Yeah.
Attorney?
Yes.
Is it?
It is. I don't have it with me, but yeah, beam, steel and concrete are both on the FE. So I think you have to like design a beam and well, suppose you know that whole list of stuff. Like, who knows if you'll actually have to do that? But beam and column are on the FE.
This stuff is actually kind of fun. It makes me feel like a real engineer. Like, this is what we actually do at the end of the tunnel.
Right? But you had to take all that before to get here, right?
I really don't think I would have needed calculus. You could have just told me this equation is true and you can believe in it, and I would have just been perfectly fine without taking calculus.
I was fine with calculus. Differential equations was something else.
Yeah. And Diffie-Q is, you really, if you go on into like graduate school, Diffie-Q comes up in like, well, for structures, it comes up in earthquake engineering. Is really the only place I've seen it.
Because I liked it.
I loved Diffie-Q. I had like the best math professor at Purdue for Diffie-Q, so it helps when you have the good professor. Yeah, Johnny Brown.
Almost all of us took it online, so none of us know what's going on. I could not solve you the most simplest Diffie-Q equation. I have no idea what I'm doing with Diffie-Q.
I took it in class.
Yeah, you and Little John and like Patrick, I think, took it, but
Yeah, but it cooked Patrick's goose. He was done after that.
yeah. And then Little John dropped off too, so you're the only one that knows how to do Diffie-Q.
He didn't drop out of math though.
No, he didn't.
He went to a math.
I haven't seen him though since he switched majors. Like, I have not seen him at all.
Yeah, that's no surprise. He went to a different building.
Yeah, yeah, well, if any of you end up in like end up in structural engineering grad school and take earthquake engineering, my recommendation is the first week of school, solve the differential equation, and you will be good to go for the rest of the semester. I did that and I aced that class. So anyway, but I know y'all are just like, I just want to get to May and graduate. Don't tell me about grad school.
Many times as they have told us that they're going to do away with our program at UALR, it creates a very high level of anxiety to get through the program before it's gone.
Well, I never say never, but the good thing is, like, when it came to like the retrenchment stuff, we have a very, very strong advisory board for our department. And the construction industry especially has a lot of money and sway. So they all went to bat for us.
Awesome.
Anyway, so I'm just gonna write down some of the numbers that I got. I think at least half of you got the right answer. I got a D of 21.37 inches. Remember, you actually have to calculate a D, not estimate it, because you know your dimensions now. I got an A of 6.4 inches, corresponding to a C of 7.53 inches. My strain and my steel, because it's only one layer, was 0.0055. So it's greater than the yield. It's also greater than the yield plus 0.003. So my stress is equal to my yield stress, and my fee is equal to 0.9. Right? And from there, I got my fee MN of 415. Now we didn't do it because I just ignored it, but you also need to check AS min just to say you did it. Clearly 4.26 inches of steel is gonna meet that requirement, but you never know. It's always good to double check it anyway. So
The ASMN was only like 1 inch squared.
yeah, it is, right? It's only an inch squared. You're fine. I'm just being lazy. So, did anybody not finish or have any questions getting to that point? If you want to go ahead, I think some of you, I don't know if you guys finished it or not. I know at least half of you did. But those are the numbers, and you can go ahead and work it out yourself, maybe while you're preparing for the exam. When is the exam? Is it the 4th? Or the
Yeah, it's like right before the AC.
It's the 5th. Yeah, I know. I looked at that. I was like, you got the AC exam, you got a senior design deliverable.
Marcy did the same thing, so our highway is like that Tuesday.
Yeah, it's like 6 things do that. Oh,
Did y'all say it was due that the test was the 5th?
I think it's the 5th.
I'm taking the FE on the 4th.
And you're just gonna laugh at him? That's not funny. Hey, at least you don't
And
have
the
to take the
AC
highway
on the
test.
7th.
Yeah,
I did my time in highway. Thank you.
that's true. That's true. So, yeah. Well,
You know a test is bad when JT looks at you like, what is going on?
I know. I hope this fall is better than last fall. Anyway. Yeah. In terms of that class. Yeah. I was talking to Caleb the other day and I said, it's not your senior year if you're not stressed out.
Well, I guess it's been my senior year since I started.
I guess it's my senior year then because I'm very stressed out.
Yeah, I get it. It was a very tough year.
the first year that you guys have decided to do the engineering design project the full year?
No, we've been doing that since before I was here.
So this was the P seminar was, okay.
Yeah. Yeah, I think that's been since the beginning. I'm not entirely sure. I was not the person in charge at the beginning, so. Anyway. Well, if you guys want to practice, so we have an exam in 2 weeks. It'll be on the design of beams, and I'm going to cram in the compression, and I probably shouldn't cram in shear on the exam. Shear is like a day. It's not hard. And then we'll do columns right at the end. And yeah. But so if you want to go, and while you're practicing for the exam, if you didn't get these numbers, go back and check those are the answers. So with that, does anybody have any other questions? My daughter was sick on Monday, and I told my husband that I told the teacher that she was just going to stay home and do virtual work. And my husband was like, yeah, just add a unit load. And I was like, oh God, we're engineering nerds. I'm teaching virtual work and structural analysis right now too. They didn't appreciate my joke, I don't know. Anyway. Okay, well, I hope you all have a good rest of your day and weekend. And yeah, let me know.
That's why you're gonna stay and bug you about senior design. So
Okay, I can do that. Yeah, if you guys need to stay after and ask questions about this or whatever, go ahead. But I'm done with the lecture for the day. So. Maybe other people are sticking around to ask questions too. Yeah.
Ask away, Caleb.
I'll say the same thing to you. You go.
We don't know what we're doing.
Can we just turn on some Hamilton? No. All day I was talking about virtual work, and I was just like, I'm looking for a mind at work.
That's funny.
I've been saying, I don't know.
So we started yesterday. We tried to do like designing for a typical beam and a typical spandrel beam.
Mm-hmm.
So we use our dead loads and live loads from deliverable 1, right?
Mm-hmm.
Yeah, 1.
Plus, I emailed Callahan about for spandrel beams having like a wall weight and adding that into your dead load, and he gave us a number to use for that. So when you calculate for that, don't you have to draw your beam out and get like a maximum moment, right? And that's what you base your, is that what you're gonna base your steel section off of? Like, do we need the steel manual?
Yeah.
And go back and find, is that the right idea?
Yeah, you just have to, you calculate your loads. So you use your tributary area for your PSF or whatever to calculate your linear load.
Right.
And then you use your loads to calculate your maximum moment. And you pick up your steel manual and look at the length, right? It's based off of, I have it right here.
So I brought my steel manual today because I was going to try to do some. So like I got a maximum moment of 198. So I'd go to tension, right? And look for a typical W section.
You go to beam. Tension would be an axial load.
Duh. See, this is why I stayed around and asked you.
So,
and we're using LRFD, right?
Yeah. And that's maximum load. I don't know what the. Oh, and you can use like the table. It looks like this, right?
Yeah.
No, I never learned how to read that. That was some BS.
Yeah.
Never used that.
So, but all you need there is your unbraced length and your required moment. So what's your unbraced length?
32.5.
And what's your moment? 190 kip feet?
198. So we would use
your
W16 by 31.
Yeah, hold on, let me.
That's what I got. I was just using the wrong tab then. That's why I was so confused.
Okay. Yeah, you'd say like 30.5 or something like that.
Yeah.
So yeah,
You're
12
using the chart?
Yeah, the chart, I got a 12 by 58.
Okay. And using the tables, I got a 14 by 34. So how can they be that far off? Which column do you look at if you're looking at the table?
Well, I think that's why.
MPX or
What page are you on?
3-26. And 16
That's
by
why.
31.
And this is where you guys actually did not do terribly well on that final. Now, granted, it was COVID, but so 3-26. So you're unbraced. So what you're at, like a 14 by 34.
Yeah, that's what I.
So your what, 12 by 50. Sorry, I'm thinking through some stuff here. By 58. So your unbraced length is 32 feet.
32 and a half.
Actually, well, here's a question. Is it unbraced the entire length?
Yes.
As far as I know, yeah, that's from column to column in our schematics. Using our schematics, like the dimensions we got.
What's on top of it? A slab.
The next floor, but
A slab. Is the slab providing continuous bracing?
Yeah.
so this is for the floor, is what you're saying?
Yeah.
Well,
I mean, that might be a good question. I mean, now I'm questioning myself, but that might be a good question to ask on the Google groups. Is the floor slab providing continuous lateral bracing?
And if that's the case, then you can use this chart.
Well, you can use that chart either way, but if that's the case, then your unbraced length is 0. And if your unbraced length is 0, then your capacity is your plastic moment, your VMP.
Yeah. And in that case, we'd use what I said, right? You'd use a 16 by 31 or a 14 by 31.
Yeah, 16 by 31. Yeah. But that might be just to verify that in the Google groups.
Just to clarify.
Um,
Okay.
But yeah, that's a smart question to ask.
I feel like a bozo because I ask Callahan a lot of questions. I do. I've been emailing him.
That's okay.
He seems to be the only one from Cromwell that's actually like participating.
Well, yeah, because so there's two structural guys, Mike and Paul just had a baby. Well, his wife did, like a month ago. So, he's usually, you guys haven't even met him, but he's a younger guy, like really active generally, but yeah, life.
He's stressing out just as bad as we are. I understand.
Yeah. So, yeah. Now, if they say no, it doesn't provide continual bracing, then you need to. I'm going to share my screen. And just draw on here. But if you remember from, right, this is your unbraced length. And this is your FMN. There was like this, and this, and then like this, I forget, something like that. Like talking out of my butt here. But this is your plastic length, and this is the difference between inelastic and elastic, which I think is like that. And if you look at that chart on 3-26,
It gives you a value for LR.
LB and LR, and if your LR, it says, is like 11.8 feet. So you're way out here at 30 something feet. If your LB is 0, then you're obviously like here. Oh, way out like.
So you're saying
If you
our length should be less than LP?
No, it doesn't have. I think it is because it's continuously braced. That's just a question to ask. Because
Gotcha.
Your moment capacity is going to depend on your unbraced length. If you are less than your LP, then your FMN is your plastic moment. If you're between these two, you have to interpolate. And it gives you the equation to do that in the beam section. If you're out here.
I remember doing that from the steel, yeah.
If you're out
that's on
here,
like a chart, isn't it?
Yeah, and that if you're out here, if you actually want to calculate the capacity, I think you might have to go back to the spec. Because I think out here, it's me. Oh, I'm not gonna make it up. Let me see, flexure. If you're out there, then your FMN, right? If you go back to the spec, is your critical stress. We gotta add a fee in there. Times your section, your elastic section. If you go back,
do you know how many corrections there's going to be on this deliverable?
Well, that's why it's good to ask the questions now and maybe fewer. Ask the questions now. It's really kind of frustrating if you guys come in and say, well, we had a question about this. You just didn't ask it, and you just made an assumption. If there's something that you're really confused about, just ask it now, and then you don't have to say that later. But
yeah, but I would have never asked that question. I would have never thought about it being unbraced length. I'd have been like, oh yeah, that's my number, 205. We're rolling with it.
Right. Yeah, and that's where I wonder if I still have Josue's shady. I'm being silly. I don't know. Do I not have it? I don't have it. I might put it somewhere else. But the AISC, the chart, the steel manual. If you go to beams.
Are you looking at table 3-6? Is that the one?
I was looking at table 3-10. The charts. You enter.
Okay.
You enter the chart. Let's see if I have another empty page. Yeah. You enter the chart, and it has it basically has a bunch of those things, but it's like it would be a giant chart on like your wall, and they've just broken it out. So you would go to the chart and enter your unbraced length at the bottom and your required on the left, and it has dashes, remember, and it has straight lines. And if you're like here, you go to the next solid line, not straight line, solid line. And that's your section. But then you do have to go back and actually verify that the capacity is what you think it is, which is where you either need to use the spec equations or the tables if you can, if that makes sense.
Yeah. So this is where you got, originally you had 14 by 61.
I got,
right?
well, no,
Using
I
this
got,
chart.
I got 12 by 58, but because I was on page
122 should be.
122, and I go at 30.5 and 198. And I'm just below that 12 by 58 solid line.
Yeah, because it's 32.5. So yeah, you would get
32, 32.5, so yeah, you'd be 14 by 61. Yeah.
So you're saying if he tells us that it isn't braced, we need to use the chart like this.
Yeah.
And work with our, and if not, we're good to use table 3-2.
Yeah. If it's continuously braced because of the slab, then your LB is 0, and you can just use your VMP. If it's not braced for that 32 feet, then you're going to have to go, then the chart is the easiest. I mean, there are other tables that you could look at, but the chart is the easiest place to start.
No.
And then go back and calculate your actual, like the chart will say, okay, a 14 by 61, but you're going to want to know what that actually is. You might be able to read it from here, but I don't know. I would personally use an equation or the tables.
Okay. Now, for spandrel beam, we're going to use that wall weight, but for a typical beam, like in the center of the room, you're just going to use the dead and live load that he gave us, right?
Right, and the tributary area onto it.
Yeah. Okay.
Yeah.
Okay. Cool. That'll get us started.
Yeah.
I'm sure once we get to like columns and stuff, we'll be super confused again, but.
I know, these are good questions, and it'd be a good question to ask in the Google Grapes to say, should we assume that the slab is providing continuous lateral bracing?
Okay. We can do it.
So, yeah. And now you guys are a step ahead by asking this question already, and I just kind of gave you the answer. So.
Oh,
right.
Thank you.
Well, see, like I said, I got to the 198, but when I went and looked, I automatically went to the tension section because I think that's the first tab we used, and that's why it wasn't making any sense. I was like, there is no way that this is right.
No.
I was just in the wrong tab.
We're designing beams, so we're going to be in the beam section.
Right. Okay. All right.
Okay.
Thank you.
Good now? Okay.
That makes sense.
I mean, not good, but I feel better.
Can you give me some estimating answers now?
Yeah.
I will punt that.
Not your fortune, right?
Yeah, Daniel is probably the best person to ask aside from Chris Ray if he helps you.
well, they're both like confusing. So they've given me different answers for the same thing sometimes. So.
Well, Daniel's the one who's gonna be
He's grading it.
keeping it, so I would defer to him. I know. I was thinking the other day, like one year I should like be my own group and like actually do this stuff.
Yeah, you get B's like the rest of us. They're turds. I worked so hard on this thing. We got an 80. I was like, what the heck?
They graded super hard. It took me so long to do this stuff.
I know, I get it. And the grade part, work your hardest, okay? We'll figure out the grade part at the end.
Good.
But, no, my senior design stories are terrible. I didn't want to be in charge because I didn't want to be the woman in charge.
Responsible.
The woman in charge of 5 men. And our first deliverable, I was super busy and I was really hands off. And our first deliverable, we got back unacceptable. Because I went and looked and there were like incomplete sentences and it was terrible. I had a person in my group who went by the name Nacho, which I think just tells you like everything about. And so our second deliverable, we only had 2. Ours is only a semester. But our final report, I like didn't sleep for a week because I was writing it for them because I was like, you guys are dumb. So it's frustrating, I know. And
Yeah, I'm going through a lot of insomnia from all this anxiety. So
I'm sorry.
I don't think I've been to sleep in 2 days.
That's what I'm, I had some health issues related to my senior semester. I get it. It stinks, but
We just gotta keep pushing to May. That's what I keep telling myself.
yeah, and
5 more months, I'm out of here.
I hope you guys really just appreciate. I know it's a big project, and especially for not as much credit wise, but it's a really cool opportunity to actually sit down for a whole semester, for a whole year, and meet with professionals. You know, like.
And have them drill you and tell you how stupid you are.
No,
It's really cool.
I hope you look back on it with appreciation. You're like, I just want to graduate.
Maybe in a couple months.
You're like, I'm not there yet. I get it. So, okay.
I guess we'll get off here because now we're supposed to meet and talk about your report that's due Monday. So, yay.
Have fun with that.
Bye.
Bye, guys.
Thanks for the help.
You're welcome. Bye.